Welcome to the Microsoft Certified Azure Data Fundamentals training course. Let me briefly introduce myself as an instructor. I have experience in developing the enterprise systems and the cloud architecture for some major companies. Besides this course, I offer tutorials on cloud services and programming on Udemy and YouTube. I also offer courses to prepare for Azure certification exam and tutorials on other cloud services like Google Cloud and AWS on Udemy. This course is dedicated for those who want to pass the Azure Data Fundamentals exam. It covers key points that will appear on the exam and includes about 6 hours of video explanation. It covers all the services within the exam scope. With hands-on videos, you can engage in the practical learning, and it also provides sample questions for you. In closing, I sincerely hope you pass the exam and elevate your skill further. Thank you for listening. In the YouTube version of this course, it includes a presentation slide. And for comprehensive course that include hands-on training and practice tests, please visit my Udemy course. Check the description for more details. So let's start it. Welcome to the DP-900 Azure Data Fundamentals training course. This course is divided into 4 main sections. In Section 1, Microsoft Certification Exam and Preparation, I will introduce an overview of the exam and some tips on how to study for it. In Section 2, Introduction to each service, I will cover all the services that come up in the DP-900 exam. And Section 3, the practice question, I will provide the insight and the guidance on taking the exam. And lastly, in Section 4, a summary, I'm going to introduce additional learning resources. Alright, let's start Chapter 1. In this section, I'm going to introduce an overview of the Microsoft Azure, the details of the certification exam, and how to set up an account. First off, let's talk about what Azure is all about. The Microsoft Azure is a cloud service provided by Microsoft. It is the second largest after AWS. They started the business in the late 2000s and changed its name to Microsoft Azure in 2014. As of now, they offer more than 265 different services, with new services being released every year. And these are examples of Azure services. There are more than 260 services, so this is only a partial. Not only infrastructure as a services, for example, virtual machine, storage, and networking services, but also they offer services such as gaming, AI, machine learning, and so on. In Chapter 2, I will introduce the major services that appear in the exam by each categories. This is the share of the cloud market. For the past several years, AWS has been the first place, Azure in the second, and the Google Cloud in third. AWS and Azure account for more than half of the total market share. Azure has the 26% market share and is expected to continue to grow in the market. You are well worth learning Azure. And this is a comparison between cloud and on-premises. One of the primary advantages of the cloud service is the ease of deployment via internet. Also, you pay for what you use, which often means a reduced cost for the user. But the benefits of the moving to the cloud are not just about the cost saving. The standardization at the infrastructure can also simplify the management. And lastly, for your reference, I'd like to introduce the comparison chart for the three major cloud providers given by Google Cloud. All three cloud providers offer similar services. If you have experience with Google Cloud or AWS, this comparison helps you understand Azure well. Next, I will introduce overview of the certification exam. And before we start, I want to talk about something that might sound a bit preachy. You might see the people online comment like that I passed in just a few weeks, or I passed even though I am beginner. But remember, the way of learning is different person by person. Your background, how fast you learn, and your personal and work life, all these things affect how much time you can dedicate to studying. It's important to find a pace that works for you. When it comes to studying, there is no one-size-fits-all approach to studying. A learning style is different by person, and the time needed to pass the exam is also different by person. Easy and hard are subjective, and not just a universal truth. In addition, Roma was not built in a day. Engineering skills are built over time. The IT world is rapidly evolving, so there's no end to learning. Make the most of any free time and find a suitable way to keep learning. Earlier I told you that the way of studying differs from person to person. In this course, I will be breaking down the Azure service by category and after that providing the practice questions. Whether you want to dive into the lecture first or tackle the question is totally up to you. Thanks to platforms like Udemy, you can easily learn technology and business skills. And this means the more willing you are to learn, the more you can grow. The benefits of the on-demand learning include, as long as you have internet access, you can learn anytime and anywhere. And you can attend the lecture by popular instructors, regardless of where you are. And it's flexible. You can adjust the playback speed and revisit the specific sections. The drawbacks of the on-demand learning include, unlike classroom, you may find it difficult to concentrate. Because the teacher-student relationship is one too many, it's hard to ask questions in real time. But in this course, I will try my best to answer your questions. And here is a list of Azure certification. Microsoft offers 3 levels of certification: the Fundamentals, Associate, and Expert. The Fundamentals exam is for beginners and it's the gateway to every certifications. The Associate exam is for intermediate level, the candidate with about 2 years of work experience, and the Expert exam is for advanced level candidate with 2 or more years of work experience. A DP-900 is categorized as a database and includes a question on services such as database and data analytics. The Azure certification expires 1 year, but DP-900 has no expiration date. And here is the flow for taking the exam. And first you need to create the personal Microsoft account. You need a personal account, not a corporate account. Specify the date and the location of the exam on the Pearson view. You can also take the exam remotely. At the exam site, you will be required to bring an identification to complete the entrance procedure. You don't need writing material for DP-900 because there will be no calculation questions. The result of the exam can be checked immediately after on the site. If you fail the exam, you can take it again after 24 hours. If you fail the exam a second time, there is a 2-week interval before you can take the exam a third time. In addition, you may take the test at the most 6 times in a 12-month period for fairness. At the associate and expert level, the certification is valid for 1 year, so you must renew your certification. You will be notified 6 months prior to renewal. And the renewal process is not difficult and you can take it online. And next, I'm gonna introduce DP-900 exam guide. I recommend you review it before taking the exam because it often updates. The audience profile is the candidate who can demonstrate their knowledge of core data concept and related Azure services. You should be familiar with the concept of the relational and non-relational data and the type of the data workload such as transactional or analytical. The scope of the question is describe cloud data concept, identify consideration for relational data on Azure, describe the consideration for working with non-relational data on Azure, describe an analytics workload on Azure. This course is comprehensive and includes application of the exam content that will appear on the DP-900 exam. The exam is worth 1,000 points and the minimum passing score is 700. The exam has the multiple choice, drag and drop, hot area, and the repeatable patterns. That there are multiple exam format, but you don't need to do any special preparation. As DP-900 is a fundamental level, it's not difficult to pass if you stick to the basics. And lastly, here is a sample question, and this is a question in which you choose one of 4 options. I have prepared the practical question at the end of this course. Next, I will introduce overview of the basics of the cloud computing. And first, I will introduce the basics of the cloud computing. The cloud computing refers to the form of service offering to the clients via the internet. And traditionally, it's common to provide the hardware your own physical data center. But since the 2000, the cloud computing has developed as a software and data can be exchanged online. And the physical data center is often called the on-premises. The cloud computing was first proposed as far as the 1997. The cloud computing became popular in the 2000s. In recent years, by improvement in network performance, you can transfer the large-scale data and stream data. The demand for cloud computing is increasing every year. In contrast to a personal computer, a server provides a service that is used by many people simultaneously. You can access the server over a network. Multiple clients access the multiple server in a data center via the internet. The client sends a request to the server, which processes the request and returns the response. The data center leases a portion of its server to the clients. They logically assign the compute and storage. The data center provides the independent power supplies for each server rack to maintain redundancy. If the power supply for some server racks fails, another rack can remain operational, which minimizes the failures. Generally, it takes several days to install physical server on-premise side. It also takes time to dispose of the servers when they are no longer needed. On the contrary, with the cloud, you can rent servers, storage, and network equipment in the data center on demand. You can deploy cloud architecture with small steps. It also optimizes cost because the cost of the server are on pay-as-you-go basis. Next, I will introduce the features of the cloud. Now, first, let's talk about availability. Availability refers to the degree to which a service is usable during the time it is provided. For example, a system with a 99.9% availability is operational for 99.9% of the time. In other words, the system being down for no more than 0.1%, which equals to the 8.76 hours per year. And the redundancy means the inclusion of extra system component in case of failure. For high availability, in addition to the main server, prepare an alternative server and switch to the server in the event of failure. However, running multiple servers at the same time increases the cost. You need to decide the service level and consider the balance between the cost and the service. The Azure is currently available in 60 regions and over 140 countries, and this number is growing year by year. A region is a geographical area that has more than one data center. Each region has multiple availability zones. Availability zones are a physically independent data center within the region. Availability zones do not share power or cooling equipment with which you can improve the redundancy. For example, in the US, there are 9 regions, East, Central, and West. The data center for US are located in Virginia, Texas, California, Washington, and so on. To maintain redundancy, you can deploy services across the multiple region or multiple availability zone, and which is called a multi-region or multi-AZ. A region with the same geography are called a region pair. For example, US East and US West are region pair. You can improve the redundancy and availability by storing the data in region pairs. It's important to implement a disaster countermeasure to ensure the business continuity in the event of disaster in the region or availability zone. With DR, you can achieve fault tolerance and high availability of the system. RPO is a time from the point of failure to the last backup, and RTO is the time required for recovery after a failure. In general, the shorter the RPO and RTO, the higher the cost. Next, I'm going to introduce scalability. The scalability is the ability of the system to handle the increased load. The vertical scaling involves the adding more resources like a CPU or memory. Increasing the performance of the single server is called scaling up. Conversely, reducing the performance is called scaling down. And horizontal scaling involves adding more servers to handle the load, distributing the workload across the multiple machines. Increasing the overall performance by adding the number of servers is called scaling out, and reducing the number of servers is called scaling in. With cloud computing, you can increase or decrease the number of servers with just a few clicks from your browser. On the other hand, adding or reducing the server on-premise is a huge hassle. And also, by working with the monitoring tool, you can configure auto-scaling. And next, I will introduce billing model of the cloud. Pay-as-you-go is a billing model where you pay only for what you use. By migrating from the on-premise to the cloud, you can shift from the CapEx to OpEx, effectively turning fixed cost into the variable cost. And this is particularly beneficial for the company with limited capital, like a startup company, as you can reduce the upfront investment in physical server and achieve profitability sooner. The costs in the cloud vary by service, such as virtual machine, storage service, and data transfer, and typically increase with a higher specification. The cost benefits of the cloud migrations are not only a pay-as-you-go model, but also you can reduce the personnel and data center lease costs related to the on-premise operations, and cut software license cost, and leverage the economy of scale to lower operational expenses. And next, I will introduce the categories of the cloud computing. The first one is based on the level of the service provided, which includes the SaaS, PaaS, and IaaS. And SaaS stands for Software as a Service, a cloud service that provides application over the internet. You can easily adapt these applications without installing the software. However, the cloud provider manages everything below the platform level, which may limit the customizations. Examples of the SaaS include the office software, webmail, and online storage. PaaS, or Platform as a Service, offers the cloud services like operation system and middleware. It can provide the development environment and database services in the cloud. Compared to the SaaS, PaaS offers more customization, though it requires you to have design and development capabilities. IaaS, Infrastructure as a Service, you can customize infrastructure components such as servers and networks over the internet. It is the most fundamental cloud service category, requiring you to configure everything but the physical layer. You can flexibly customize, but you have the responsibility of designing and managing the service on your side. There is a concept of the serverless computing. A serverless refers to the services that do not require server management. With the serverless model, you can focus on the writing code without worrying about the infrastructure management. The cloud provider manages the physical server, virtual machine, scaling, and maintenance. In cloud computing, there is a concept known as the shared responsibility model. In an on-premise environment, you are responsible for managing the entire physical setup. In contrast, the cloud provider takes on the responsibility of managing the physical infrastructure in cloud services. IaaS offers the most flexibility, with you taking a responsibility for everything above the infrastructure layer. Generally, the cloud provider's responsibility increases from IaaS to PaaS and to SaaS. And next I'm going to introduce another classification of cloud computing, public cloud and private cloud. The public cloud is the concept that the multiple clients share cloud resources. Generally, the cloud refers to the public cloud services. The private cloud is the exclusive cloud resources used by a specific client, often due to the security policies that prevent the server sharing with other companies. And hybrid cloud is a combination of public and private clouds. The clients generally use the public cloud, but use private cloud for function with higher security requirements. So that's all for the explanation of basics of the cloud. And these cloud classifications are always included in the exam. I'd like you to have a good grasp of the definition and use case of the cloud computing. Next, I will introduce the fundamentals of the Azure. Here I'm gonna explain the management level and the hierarchy, region and availability zone, and the Azure Resource Manager. The first one is management level and hierarchy. I'm going to introduce the tenant and the subscription. A tenant is an instance of Microsoft Entra ID. It will be automatically created when you sign up a Microsoft Cloud service. A tenant is a single organization and its primary directory. It can be used to manage users, provide them access to resources, and manage subscriptions. The Azure Active Directory has been renamed Microsoft Entra ID since 2023. And next, a subscription is an agreement with Microsoft which provides you with a billing account for the services. It's essentially a logical container into which resources usage is reported, billed, and paid for. Each subscription can have its own payment method and policies with which you can organize the resource and manage cost. For example, if you are a corporate accountant, having multiple subscriptions for different departments makes it easier to manage payment. There are multiple types of purchase options. If you are an individual using Azure, you would use MOSP. If you are using Azure as a corporation, you would use the Azure in Open, purchasing through the CSP, SCE, or EA. For your information, Azure's offerings are updated frequently. You can check the currently active and terminated plans on the official website. The Azure provides 4 levels of the management: the management groups, subscription, resource group, and resources. Management group help you to manage access policy and compliance for multiple subscriptions. These levels have the parent-child relationship. The policies defined at the management group level are inherited by its child subscriptions. And a subscription logically associates user account with the resources. Each subscription has its own set of quota. You can manage the cost and the resources on per subscription basis. And the resource groups are a collection of resources that facilitates the deployment of the resources such as application, database, and the storage account within Azure. A quota refers to the limit set on the resources you can consume within your subscription. For example, you can set 10,000 management groups per directory. A management group tree can have a root level and up to 6 additional levels. Each management group can only have one direct parent, but can have multiple child groups. Additionally, there are limits on connection, storage, and APIs. And for some cases, you can request quota increases. And these quotas are often changed, so you don't have to memorize them. But it's important for you to consider these constraints when you design and manage systems. And next one is region and availability zone. Regions and availability zone are very important concepts to learn about Azure. A region is a geographical area in which Azure provides services. You can access almost any region in the world as long as you have the internet connections. However, you should deploy your resources to regions that are geographically close to your users as much as possible. The services deployed in the region are called regional services, and the region-independent services are called global services. The Azure also has the concept of the region pair to achieve redundancy. A region pair is a combination of physically distant regions. For example, US East and US West are region pair. If data storage is stored in the region pair, and a failure occurred in one region, service can continue in another region. And this is for your reference. The Azure has several special regions: Azure Government in the US, Azure China, and Azure Germany are special regions. Due to local regulation, the three regions cannot be accessed without a special process. And next is availability zone. Availability zones are logical data centers within each region. There are 3 or more AZ within a single region. Availability set is a set of server racks that are set up for redundancy within the single data center. If hardware fails in the server rack, the service can continue in other. The Azure offers 3 types of redundancy configuration: multi-region, the multi-availability zones, and the availability set. And by the way, AWS and Google Cloud also have the concept of the region and availability zones. I will introduce the fault domain and the update domain. A fault domain is the logical group of underlying hardware within the Azure Data Center. The fault domain is the area where power supplies and network equipment are shared in rack, providing the redundancy in the event of a failure. An update domain is a logical group of underlying hardware that can undergo an update or maintenance activity at the same time. For example, the image shows the 2 update domain for each 3 fault domains. The service will continue even if the 2 of the 3 fault domain fails. Also, if one of the update domain is updated, service can continue in other update domain. Next, I'm going to introduce Azure Resource Manager. Azure Resource Manager, or simply ARM, is a deployment and management service for Azure. You will use ARM when you access Azure resources in any way. Because Azure is a cloud service, you operate it via the internet. You manipulate resources on Azure via Azure Portal, Azure PowerShell, Azure CLI, and REST clients. On the following pages, I will introduce these tools. The Azure Portal is a web-based user interface for managing the resources. Azure Cloud Shell is an interactive shell within the browser. The Azure PowerShell is a module offering the commandlets to manage Azure through the Windows PowerShell or PowerShell Core. Azure CLI is the command line tool providing a set of commands, and the Azure mobile app is a mobile application enabling the resources management from your mobile devices. The CLI and the PowerShell are outside the scope of AZ-900 exam, but I'm going to introduce them for reference. The Azure CLI or command line interface and the PowerShell are both tools for managing Azure resources, but they differ primarily in syntax and platform compatibility. The CLI is often preferred for its simplicity and cross-platform support, while the PowerShell offers a more comprehensive scripting experience with advanced features and the ability to leverage the .NET framework. Here is a sample list of the CLI command. You can perform operation by typing the commands beginning with AZ. These commands are used to manage Azure resources. There are actually numerous commands available, and you can use the combination of resource name and parameter to manage resources. I'm going to introduce the element of PowerShell. The commandlet is a lightweight command used in the PowerShell environment. They are built-in command with the verb-noun syntax like get service, which retrieve information about services. Script is a set of commandlet and logic written in the PowerShell scripting language, saved as the .ps1 files. The scripts can automate a complex sequence of tasks. And alias is a shorthand reference that you can use to call a commandlet. For example, ls is an alias for the getChildItem commandlet in PowerShell. The function is a block of code that performs specific tasks and can return values. It's similar to commandlets, but created by the user for custom tasks. The function can accept parameters just like commandlets. Again, these commands are outside of the scope of the AZ-900 exam. However, if you are going to continue learning Azure, I recommend you to learn them. Currently, there is a classic deployment model called Azure Service Manager and a deployment model using Azure Resource Manager. If you are new to Azure, you do not need to learn about ASM, because ASM is scheduled to be discontinued at the August 2024. ARM is a deployment model added in 2014 when Microsoft Azure was named. With ARM, the resources can be grouped, which allows them to be deleted in one step. You can also use template, locks, tags, and role-based access in ARM. The Azure released new services on a trial basis before releasing them to the public. These new services offer in preview status. These new services will be tested and feedback from the users before they become generally available. ARM templates are JSON files that define the infrastructure and the configuration. ARM templates consist of some sections. The schema specifies the versions of the template language. The content version defines the versions of the template itself. The parameter allows input of the value that affects the deployment's configurations. Variables are values used within a template to simplify complex expressions. Resources define the Azure resources to be deployed or updated. And the outputs returns the values from the deployed resources, often used for the referencing in other deployment or outputs. Next, I will introduce to the creating the Azure account. I will provide several hands-on lessons in this course. I think hands-on is not necessary to study for the certification exam. However, for practical purpose, I recommend the hands-on practices. First, search for Microsoft Azure on search engine and go to the Azure web page. Then you will see the page like this, where you can create an account by clicking the Start Free. The website is updated frequently, but you will usually find the button at the top of the screen. Next, you will see the pop-up asking you to create a Microsoft account. You can create a new account from here. If you already have a Microsoft account, sign in with your email address or phone number. Azure often offers the promotion for free credit for first-time user. You may get $200 free credit. In this course, you can conduct a hands-on for less than $200. Once you have created an account, you can access to the Azure portal. From Azure portal, you can access Azure services and manage your account. When you create an account in Azure, it is automatically tied to your Microsoft Entra ID. Microsoft Entra ID provides the identity and access management. This is a unique feature of Azure and differs from AWS and Google Cloud. You can also add subscription and license to access certain services or for more advanced features. Next, we will set up a cost alert. You can run this course hands-on within the free framework, but if you start up the resources for an extended period of time, you may be charged more than you should be. For example, if you start up a virtual machine and forget to stop it, you will be charged by the hour. Therefore, we recommend that you set an alert to be triggered when costs exceed a certain value. If you search for a cost in the search window, you will probably see the alert for the cost. Select Cost Alert from the menu on your left. By default, you will see no alerts to display on this screen. Set an amount for the budget. In this way, an alert will be issued when the specified amount is exceeded. For example, if you enter $50, you will be alerted when the billing exceeds $50. You can specify your own email address for the alert method. And next, let's take a look at Azure portal screen. From the left to the right, portal menu, search window, information, and account information. First, click the portal menu. From the portal menu, you can create the resources. and you can register frequently used services as a favorite. You can search for various services from the search window, enter a service name to view a service pages, document, and more. From the top bar, you can see Cloud Shell, directories and subscription, notification, portal setting, support and troubleshooting, and more. The Cloud Shell is the command line interface that can be run from the Azure portal. You can run the command line in your browser without installing it on your own local PC. In this course, we will set up a resource group and create resources under it. By creating the resources in the resource group, you can delete all resources at once when the course is finished. For example, you can set up the resource group with the name Test Udemy. Click the menu in the upper left corner to go to the resource groups page and click the Create. And from here, you can create a new resource group. Specify the name and region. Since I am in Japan and I select the Japan region, you may choose any region because the service in this course can be used regardless of the region. By choosing the region that is close to where you use the service, you can access the service with low latency. So that's all. We will finish the setting account. In Chapter 2, I will introduce each service. And these are the contents of Chapter 2, which is organized according to the DP-900 exam guide. From left to right, the core data concept, relational databases, non-relational databases, and the data analytics. The core data concept includes the data type, the type of the data storage, and the common data analysis workloads. The relational database will include the characteristics of the relational database, the SQL, and the relational database service provided by Azure. And for non-relational databases, I will introduce the services for storing the non-relational data, such as Azure Storage and Azure Cosmos DB. And finally, the data analysis chapter will include the data analysis tools, the data warehousing, and the visualizing tools. And here is an image plotting Azure services along with the data pipeline. The data factory as the data collection service, the database service, and the Azure Blob Storage as data storage services. And as for data processing and the data analysis tools, there are services such as those listed here. And the Microsoft Power BI is also available. In the following chapter, I will introduce each of these services. And this is the contents of the Chapter 2. In this chapter, I will introduce the database services provided by Azure, along with the chapter's core data concept, relational database, non-relational database, and data analytics. And first off, I'm going to introduce core data concept. In this chapter, I'm going to introduce data types such as the structured data and the unstructured data, and the types of database, the fundamental of databases, and the benefits of the database as a service. First, let me introduce data types. The general categories of the data types include the structured data, semi-structured data, and unstructured data. The structured data is a data that has predefined data type and format. With the data schema and format, you can easily retrieve and analyze the data. The structured data is usually stored in the table format. The relational databases are used to store the structured data. And here is a simple relational database sample. For example, the name is a string of the characters, and the phone number consists of the numbers. When configuring the relational database, you can add some constraint to maintain the data integrity by specifying the keys and excluding the missing values. The semi-structured data refers to the data that is not fully structured, but has some structure. It doesn't have the schema, but uses the metadata and tags to help identify elements within the data. The semi-structured data includes the document type database, such as the XML and JSON. And here is a JSON sample that records the customer information. The customer data is stored as an object, which contains a unique identifier and other information for each customer. The JSON is suitable for expressing the hierarchical structure of data. It uses the field name and value pair to represent the data. And this kind of data structure is sometimes called the key value type data. Unstructured data is a data that doesn't follow the specific format or model and for which no predefined data model exists. It is difficult to be processed in the typical database system and is not suitable for analysis in its original form. It occupies a large portion of the total data, and there are many types of unstructured data. The data formats such as social networking, web data, and media data are increasing every year. Analyzing the unstructured data enables the data-driven decision-making, including the business intelligence and marketing. I'm going to introduce data types commonly used in the field of the data analysis. CSV, the comma-separated values, is the simple format in which data records are represented by the single line and the field within the record are separated by commas. It has no schema structure, but is universally used in many applications. JSON or JavaScript Object Notation is a lightweight, text-based data exchange format. JSON is highly readable and easy to parse. In other words, it is human readable. Unlike CSV, JSON can handle hierarchical or nested data structures. Avro is a row-based storage format suitable for both serialization and deserialization. The serialization refers to the conversion of data structure into a format that can be stored and transferred. Avro is also referred to as the schema-driven, which means that the schema definitions are stored with the data. It is suitable for transferring the data between platforms. The Packet is a columnar storage format optimized for the big data analysis. It provides the efficient data compression and encoding. It can be integrated with the Hadoop ecosystem and support complex nested structures. The Apache Hadoop is a framework used for the large-scale data distribution, and which I'm going to introduce later in the data analysis chapter. In general, the column-oriented data is faster to load for analysis because data of the same nature is stored in the same columns. ORC, the optimized row columnar, like a Packet, is a column-oriented storage format. It is used primarily with the Hadoop ecosystem because of its superior performance in terms of the compression and speed. And here is an image showing the relationship between the data type and the processing efficiency. In terms of data processing efficiency, the ORC and the packets are usually classified as the lightest data formats because of their column orientation and the compression capabilities. And the JSON and the CSV, a text format, tend to be heavier in terms of the data volume and processing. And the Avro takes a variety of sizes, but usually falls somewhere between JSON and CSV and ORC and packet. In general, the column-oriented data is better suited for analysis, and it is the best practice for Azure's analytics tool to keep the data column-oriented. In this section, I will introduce the basic knowledge about the databases. A database is a system for storing data and querying the stored data. The software that manages the database is called a database management system. There are two major types of databases, relational database and non-relational database. In the following pages, I will introduce the characteristics of each. Relational databases are commonly used to store and query structured data. The query refers to the statement of the command that asks the database management system to perform a process such as retrieving data. Take these school databases as an example. The database consists of the four main tables: student, teachers, subject, and grades. Each table has a key that uniquely identifies the data. For example, in the student table, the key is the student ID. There is always one key assigned to each student. There can be no duplicate keys, and no student for whom no key exists. Keys makes it easy to manage school data, such as referencing a particular student's grades or assigning the teacher. A non-relational database is a database system that doesn't use a schema as used in the relational database. Non-relational databases are sometimes referred to as NoSQL database. And this is a typical example of the non-relational database. The key value type database, a database with a simple structure of key and value. Unlike relational databases, they are characterized by high performance since only simple and single type data is stored. A document-oriented database stores data in document format, such as JSON, and this is useful when flexible schema is needed. And the column family databases are an extended form of the key value databases that can contain multiple columns in the value portion. It can increase the processing efficiency by dividing the column into the groups called the column families. And the graph-oriented databases are composed of nodes and links that define the relationships. For example, it is used to visualize the social media relationships and network relationships. Next, I will introduce one of the characteristics of the databases, the transactions and the asset attribute. A transaction is a sequence of operations in a database management system, where the entire sequence of operation is treated as a single unit. In the IT industry, it is used to indicate the consistency of processing. In transaction processing, all operations are completed either successfully or without any action being taken. In other words, the process is never completed in the middle of the transaction, leaving the data in a half-finished state, and this is called atomicity. ACID properties are the fundamental concepts that ensure the database transactions are processed reliably. Atomicity, and this means that all the operations in the transaction are completed, or if even one fails, all transaction is rolled back as if it never happened. And consistency refers to that after a transaction moves the system from one consistent state to another consistent state. A transaction never leaves a database in a half-finished state. Isolation refers to the even if the multiple transactions being executed simultaneously, each one is operating independently. They do not interface with each other. And lastly, durability. Durability assures us that once transaction has been committed, its results are permanently stored, even if there is a system failure. Now I will use a specific example to illustrate what ACID properties are. Let us consider the scenario in which $100 is withdrawn from the Mr. A's bank account and added to Mr. B's account. Regarding the atomicity, if the system crashes before the money is added to Mr. B's account, the transaction is completely rolled back, and the money is not withdrawn from the Mr. A's account. And for consistency, before and after the transfer, the total amount of money is in the system remain unchanged. In other words, the $100 withdrawn from the Mr. A's account is accurately reflected in the Mr. B's account. And for isolation, after Mr. A's transfer is completed, it is reflected in the Mr. B's account. In other words, it is not reflected in Mr. B's account before the Mr. A's transfer is completed. And for durability, once the transfer operation is successfully completed, the result is permanently stored in the database system. Even if a failure occurs in the system, the data is not lost. A typical database operation includes the create, read, update, and delete. And these operations are sometimes referred to by the acronym CRUD. The database operations are performed using the language called SQL, which supports the CRUD operation. Within CRUD, create, update, and delete make changes to the database itself. A read, on the other hand, does not modify the database, but retrieve data from the database. And therefore, when considering the performance impact of the database, it is necessary to separate the write operation from the read operations. Next, I will introduce OLTP. Since the 1990s, with the widespread using of the Internet has made it possible to operate the database system remotely. A system that processes the transaction online is called OLTP. Especially in the large systems, it is necessary to process the transaction from the large number of users. The OLTP requires consideration of design that separates the change operation, such as writing and the updating the database, from read operations. And for data analysis, a read-only or read-mostly model is typically used. In the read-only model, the data analysis is based on the snapshot of the data extracted at the specific point in time. And data for analysis can come from the variety of data sources, including the OLTP system. Once the data from the data source is stored in the data lake, it is processed and extracted as needed. The processed data is then fed into the data warehouse or data mart. The data analysis then executes a query to the data warehouse for the reporting and visualization. And since the data analytics rarely perform the write operation on the data warehouse, a read-only model is usually used. In general, a database experiences a greater performance impact from the write operation. For big data analytics and other processes that require efficiency, it is common to separate write and read operation. The concept of the big data analysis and the data warehousing and the data lakes will be introduced in the separate chapter on data analytics. Here I'm going to introduce the general advantages of moving your database to the cloud. And for reference, the database services provided in the cloud are sometimes referred to as a database as a service. And first, there is a simplified management. Compared to the on-premise solution, the cloud computing of the database eliminates the need to manage the physical servers. The management tasks such as the upgrading the OS, the database management system, can be automated. It also provides functions to automate tasks such as backups. By moving the database to the cloud, the availability can be improved. Since Azure is configured with the data centers around the world, the database can be distributed across the multiple availability zone or region to improve the redundancy and availability. Additionally, by having the data backup in another region, the service can continue in the event of failure in the primary region. A third benefit is a simplified performance tuning. Since the cloud allows you to logically increase or decrease resources such as the computing and storage, and you can flexibly scale the resources according to the volume of access and queries. A fourth benefit is the reporting and monitoring capabilities. Azure has monitoring tools such as Azure Monitor that allows you to monitor database resource and performance. You can also get detailed per query metrics as needed. A fifth benefit is enhanced security. Azure provides the encryption and the data protection tools that can be used to improve the database security. The Azure also offers services that conform to the laws and regulations of each region, making it easier to meet the compliance requirements. And the final benefit is the price optimization. Since there is no need to prepare the database server from scratch, the initial investment can be reduced. Additionally, since the fees are based on the pay-as-you-go basis, the operating cost can be optimized. And next I'm going to introduce the base. The base is a set of principles for the database that focus on the high availability and the tolerance to network partitions, with eventual consistency rather than immediate consistency. It stands for the basically available. The database appears to work normally most of the times. And the soft state, the state of the database may change over time, even without input. And eventually consist means the database will become consistent over time, but doesn't guarantee immediate consistency. The acid and the base attribute are sometimes used in contrast. In cloud services, the database and network latency can occur because the infrastructure executes while connecting the multiple servers over the internet. So it becomes difficult to maintain the strong real-time consistency. In the cloud, it is common to sacrifice temporary consistency to guarantee the eventual consistency, aiming for the convenience and cost optimizations. Next, I'm going to introduce relational database. In this chapter, I will introduce the basics of the relational database and the relational database services provided by Azure. And the fundamental of the relational database includes the database constraint and normalization and SQL and the general relational database functionality. The Azure provides the relational database services for both the Microsoft SQL Server and the various open source databases. I will introduce the features and usage of each database in this section. And firstly, I'm going to introduce the fundamental of relational databases. And this is the history of database. The theory of relational databases was established in the Edgar Code of the IBM in the 1970s. And in the 80s, the commercialization progressed and the Oracle began releasing the commercial database. Additionally, SQL became widespread as the standard query language. In the 1990s, the online transactional database became common as the internet gained popularity, and in the 2000s, the demand for more flexible database increased, leading to the emergence of the NoSQL databases. In a relational database, the data is modeled in the matrix table. Each item records homogeneous information. In other words, each record stores items of the same type. For example, this student table contains the student ID, name, and the email address. The student ID consists of the 3-digit number, since the student ID is the key that uniquely identifies the student, and duplicates the keys are not allowed. Null values are allowed for middle name, since some students do not have one. On the other hand, first name and last name cannot be null. The email address must be formatted as the string followed by the @ symbol. In this way, it is common to set the constraints on the database to ensure data integrity. And such constraints are standardized by ANSI. And I will introduce the database normalization. The database normalization refers to reducing the data redundancy and maintaining the data integrity. There are 3 stages of normalization: the first normal form, a second normal form, and the third normal form. And here, I will introduce the normalization using a simple example. And here is a table consisting of the part manufacturer, the place of manufacture, the contact information, and so on. And this table is not normalized, and there are multiple elements in the one item. If normalization is not done, it will be difficult to maintain data integrity. It also makes it difficult to add, update, or otherwise process the data in the database system. So I will normalize this table. The definition of the first normal form is that each column is atomic. In other words, the column does not contain the multiple values, and that the same column name is not duplicated in the same table, and that each row can be identified by a unique key. In the previous non-normalized table, the part manufacturer item and other attribute had the one-to-many relationship, but this relation has been modified. And next, in the second normal form, in addition to the first normal form, a condition is added that the non-primary key column must be free dependent on the entire primary key, and this is called the partial dependency elimination. In this case, the dependency is between the manufacturer and the place of manufacturing and the contact information. In other words, the place and the contact information depend on the manufacturer. Additionally, the price and the number of products manufactured depend on the product. On the other hand, the product and the date of manufacture depend on the manufacturer, and this does not satisfy the second normal form. And in addition, the third normal form has the condition of eliminating the transitive dependency, but there is a transitive relationship between the part manufacturer, the product, and the attribute related to it. To resolve this, the table needs to be divided. And here is the table divided into the two tables. It is divided into the two tables, the manufacturer table and the product table. And finally, in the third normal form, the condition is that the non-primary key column do not depend on the other non-primary key columns. In other words, the transitive dependency are eliminated. The table in the second normal form are further divided and managed in the three tables: the manufacturer table, the product table, and the production table. In the manufacturer table, the key manufacturer uniquely determines the place and the contact information. In the product table, the price is uniquely determined by the product name. As a side note, the manufacturer and the product table are master tables, and the production table is a transaction table. The part manufacturers and their manufacturing location and the contact information and the product names, the price, do not change on the daily basis, but the production table changes daily. When designing the actual database system, the transactional data should be designed to allow for frequent data update. I'm going to introduce what is SQL. SQL is a programming language for managing data in relational databases. It is used to retrieve, insert, update, and delete data in a database. And there are several varieties of SQL which are standardized by ISO and ANSI. The SQL is essentially one standardized language, but the database vendor adds their own extension, so the variety of dialects exist. And since this course is focusing on the Microsoft Azure databases, and the explanation will be based on the TSQL. And just for your reference, it can be pronounced as SQL or SQL. The SQL pronunciation is common in English-speaking countries due to SQL's origin from the term, the Structured English Query Language, SQL, of IBM. There are three types of the SQL as described here. Starting in the next chapter, I will introduce the characteristics of each. DDL, or Data Definition Language, is the language used to define, modify, and delete database structure. The specific command includes the create, alter, drop, and truncate. The create is a command to create a new structure such as database, table, and index. The alter modifies the existing database structure, and the drop deletes a database table, index, or other structure. And truncate deletes all rows from the table and empties the table. And here is a sample SQL command to create a simple table using DDL. In this example, it creates a table called the customer to hold the customer information. The customer ID is set as the primary key, which must have the unique value, and the last name and the first name are not allowed to be null because of the not null constraint, and null is allowed for all other fields. And this SQL command will create an empty table, and actual data can be added to this table by executing an insert statement. A DCL, the data control language, is the language for controlling access to data in the database. It provides the command primarily related to the security and access privileges. And specifically, there is the grant to grant a specific privilege to user, and the revoke to revoke privilege from a user, and the deny, which is to deny specific privileges. And here is a sample DCL statement. The first example is a grant statement to grant a user 1, the select, insert, and update privileges on the customer table. And the second example is the revoke statement that revokes the insert privileges from the user 1 on the customer table. And you can grant specific privileges on specific command and specific table. For example, if you want to set up the read-only user, you can grant only select privileges. The DML, or Data Manipulation Language, is the language for manipulating the data in a database. It performs the operations such as the inserting, the updating, and deleting and retrieving data. The select, retrieve, and extract data from the database. The insert, which insert a new data in the database table. And the update is the modified existing data in the table. And the delete is remove the data from the table. Since the DML is the language used the most in the database operation, I will introduce each of these commands with a specific example on the following pages. And first, here is a sample select statement. Select is usually used in conjunction with the from and where. The table name follows from, and the condition for data extraction follows where. And this query retrieves information from the employee table for an employee whose department is sales. And the asterisk in the select statement is used to retrieve all information from the employee table. And as a point of reference, since an asterisk extracts all the data, the process can take a long time if executed on the table with a large number of records, and therefore it is generally recommended to extract data with more specific conditions. And next, this query retrieves the email address and the department name of the employee whose department is sales from the employee table. The previous example had an asterisk after the select, and the retrieve all columns. But this sample focuses on just the email address and the department names. And next, this query selects the first name, last name, email address, and the department name of the employee whose department is sales. It also includes the condition, the order by the last name to sort the result by the last name. And the next is the sample query that joining the two tables. In this query, joins the project table with the employee table and selects the project ID, the project name, along with the project manager's email address and the department. And here, the project manager is associated with the employee table by the manager ID and the ID. The query shortens the project table to represent it as the P and the employees table to represent it as the E. Select the project ID and the project name from the project table, and the email address and the department from the employee table. And as a join condition, the manager ID in the project table must match the ID in the employees table. And next is an example of update statement. This update statement updates the existing row. This query updates the department of the row in the employees table where the ID is 1. The command set means to assign a new value to the department field. And the next is the delete statement. And this delete loads by specifying the conditions. The where clause deletes only the record with the ID equals 1. For reference, if delete command is executed with the specifying the condition in the where clause, all rows will be deleted. And finally, here is a sample of the insert statement. This insert statement adds an ID, name, email address, and the department to the employee table. And you need to specify the actual value during the insert. Again, a DML is used for operations that add, delete, or update actual data in the database. The more transactions there are, the more writes and updates are made to the database, and which increase in the load. Therefore, it is common practice to separate the reads from the write when there are many transactions. Next, I will introduce to the functionality of relational databases, view, stored procedure, and index. A database view is a virtual table based on the query to retrieve the data from the table. It is created to reflect the actual data stored in the original table. Because it's a virtual table, the view does not physically store the data. Since views are independent of the original data, they do not affect the database performance. They are also easy to use from the security standpoint, because they extract only necessary data from the original data. The views are used to display data at the particular point in time. For example, a use case might be extract and analyze data at a specific point in time for a table that is updated daily in the online transactional database. And here is a sample query to create a view. The view is created using the create view statement, and this query combines the create view statement with the select statement. In other words, the query can be used to extract the data based on the specific conditions and create the view of the table at a particular point in time. Next, I will discuss the stored procedure. A stored procedure is a grouping of the multiple SQL commands into a single processing unit that can be executed with a single call. Stored procedures are executed on the server side of the database, reducing the amount of data exchanged over the network, and this can improve the application performance. If you do not use a stored procedure, each query returns a single result. If multiple queries need to be executed, each query must be executed individually. With considering the execution effort and performance impact, using stored procedure is more advantageous. And here is an example query to create a stored procedure. And this stored procedure is named getEmployeeInfo. It retrieves the first name, last name, and the department of the employee with the specified employee ID. And the stored procedure takes the parameter at employee ID and queries the corresponding employee information. And when executing the stored procedure, and you can specify the parameter as shown in this command. A stored procedure is similar to the function in programming. And next is the index. An index is a structure added to the table column to improve the query performance. Adding the indexes can improve query performance when there are a large number of rows. And for example, indexing the first letter of an employee's last name can increase the efficiency of a query. But the disadvantage however, is that adding indexes generally consume disk space. It can also slow down operation because the index must be updated when inserting, updating, or deleting data. Next, I will introduce the relational databases offered by Azure. The relational database provided by Azure include the services related to the Microsoft SQL Server and the various open source database services. Before introducing the database services, let's review the concept of the SaaS, PaaS, IaaS, and the serverless. And there are three main types of the cloud services: SaaS, which provides the only application layer with the cloud service provider managing the layer below it, and the PaaS, which provides the layer above the platform layer, and the IaaS, which provides a layer above the infrastructure layer. A SaaS requires the least amount of management by the user, but doesn't allow for detailed customization. For example, the server scaling and networking depend on the cloud provider. Azure's database service are also provided across these tiers. The relational database service provided by Azure includes Azure SQL Database and Azure SQL Managed Instance as a PaaS, and a SQL Server running on a virtual machine as IaaS. The certification exam will cover each of these services. In the certification exam, you will be asked whether each service is PaaS or IaaS. In the following pages, I will introduce each of these services. First, let's look at the SQL Server or virtual machine. In this method, running a virtual machine and install the database on it. Since a virtual machine is an IaaS service, you need to manage server, networking, operational tasks such as the scaling and the monitoring. It is suitable when you want to migrate a SQL Server to the Azure environment in its original form. And this kind of migration method is sometimes referred to as the lift and shift. And for reference, there are different types of migration from on-premise to the cloud environment. Lift and shift, which migrates the application to the cloud environment in its original form without changing the application configurations. And this minimizes the migration workload since the system specifications are kept as close to the current state as possible. Improve and move, which changes the configuration so that the architecture is optimized for the cloud environment after migration. And this migration workload is relatively large because of the changes in the system specification and the operational method. Rip and replace does not use an image of the existing application, but replace it with the completely new system configuration in the cloud environment. And the modernize involves a lift and shift style migration to the cloud environment, followed by the changes to the cloud optimized form using the container and other means. Azure SQL Database Managed Instance, or Managed Instance for short, it is the path that gives you near the complete control over your SQL Server. Because it is a PaaS service, the backups, software patches, the database monitoring are managed by Azure. Compared to installing the SQL Server on a virtual machine, some functions are limited. Additionally, some functions are replaced by Azure services. For example, Azure Storage is used for backups, Azure Event Hubs for telemetry transmission, then Microsoft Entra ID for authentication, and the Transparent Data Encryption, TDE, which is a cryptographic feature available in the SQL Server, uses Azure Keyboard. Azure SQL Database is a PaaS solution for SQL Server. As a PaaS, it minimizes the management. And here is a comparison table of the three services I have introduced so far. The Azure SQL Database is not fully compatible with the on-premise SQL Server. It is used for creating a new databases on Azure Cloud. And if you want to use the full functionality of the SQL Server, install the SQL Server or virtual machine, or if you prefer the PaaS solution, use the Azure SQL Managed Instance. The Azure SQL Database offers several deployment options, with a single database and the Elastic Pool being mostly commonly used. The single database is the most common option, where each database uses the resources independently. Since each database uses its own resource, it's less sensitive to performance issues and can be easily scaled. Because the resources are independent, you are charged based on the resources used. And the Elastic Pool allows for the multiple databases to share resources in the pool. It is suitable when resource consumption is uneven across different databases, making it more cost-effective overall. For example, the peak load of the one database can be covered by another database with a lower load. And this is a list of the features that are not available in SQL's database, but available in managed instance. A linked server is the function to execute the queries between different data sources. A linked server allows you to connect to other databases and manipulate data. A service broker is the function to exchange messages asynchronously between servers, and the database mail is a SQL Server feature for sending email directly from the database. And this feature allows automated alerts, report submission, and other notification to be sent via email. When deciding whether to use Azure SQL database or managed instance, consider whether you need these features. This table lists the category of the SQL services introduced so far. Again, the SQL database and the SQL managed instance are paths, while the SQL server on a virtual machine is EAS. In paths, the infrastructure layer is managed by Azure, whereas in EAS, the user manages the infrastructure themselves. In paths, availability and the scaling settings are managed by Azure, so you don't need to think about them. While EAS, on the other hand, you need to add and remove virtual machine as your workloads as demand. And also, the SQL Server version management and the updates are done on your side. And for deployment, Azure SQL Database offers a single database and Elastic Pool options. In Elastic Pooled, multiple databases share resources, making it more cost-effective. And the SQL managed instance allows for a single or multiple instances. And the pricing is generally lower for SQL database, while the managed instance tends to be more expensive because it is internally dedicated to a virtual machine. And the compatibility with the SQL Server is strong with managed instance and the SQL Server running on the virtual machine, while the SQL database is limited because some features are not available. Next, I will introduce open source database services. Azure supports several open source databases. Azure can run popular database management systems such as MariaDB, PostgreSQL, and MySQL in the cloud. The MariaDB is a database engine developed by the original developers of the MySQL, and it is compatible with both MySQL and Oracle. The PostgreSQL is an open source database engine used on the wide range of the platform. It is utilized for everything from the enterprise system to personal development. It is also extensible and has many unique features. And MySQL is another open source SQL database, currently managed by Oracle. The MySQL is widely used in the web applications. The Azure offers paths that run MariaDB, PostgreSQL, and MySQL. And you can easily take advantage of common cloud benefits, such as pay-as-you-go pricing and more efficient management tasks. And MariaDB and MySQL based on the Community Edition. On the other hand, if you want to use the Enterprise Edition, you can install the database on the virtual machine. Next, I will introduce the common features of relational databases, and these features are supported by common Azure's PaaS services. And first, I will introduce the backups and the point-in-time recovery. Azure's database automatically takes a daily backup by default, and these backups can be used to restore the database to the previous state. The first backup is a full backup, and the second and the subsequent backups are differential backups. And the point-in-time recovery is the ability to restore the database to a specific point in time. For example, it is useful when a user accidentally deletes or modifies the data. And the point-in-time recovery is performed using the transaction logs. After a failure or accidental operation, the logs or backup file can be used to restore the database to its original state. And this table summarizes the automatic backup and point-in-time recovery. The automatic backups are intended to protect the data and are performed on a regular basis. The timing and the type of backup can be specified by the user. And the backup files are retained up to 35 days and stored in the Azure geographically distributed data centers. And the point-in-time recovery is used to restore the database to a specific point in time. For example, it can be used to undo a mistaken operation, and such as accidental deletion. And here, I will introduce some common types of the backups. A full backup, which completely backs up all the data. It is the simplest method of the backups, and the restoration is faster. On the other hand, it consumes a lot of storage space and takes a long time to perform the backup. And here is an image of full backup, which backs up all the data each time. The incremental backups back up only the data that has changed since the last backup. And the backups are faster and consume less storage. On the other hand, when restoring, each backup must be combined, which makes the restoration time-consuming. And the differential backup, which backup changes made since the last full backup. And this method has a restore time and the storage consumption that is halfway between the full backup and the incremental backup. An image of the differential backup is shown in this image. Next, I will introduce the concept of maximum connections. This exactly means the maximum number of the clients that can connect to the database instance at the same time. Generally, the higher the server specs, the more connection can be made. In Azure, the number of connections is determined by the server specs, such as basic, general purpose, and memory optimized. The maximum number of the connection directly affects the application performance and scalability. Too many connections can overwhelm server resources and slow down processing speed. On the other hand, an insufficient number of the connections may result in less responsive complications, and you should monitor actual traffic and resource usage to ensure that an adequate number of the connections are available. Next is timeout. A timeout is the response time limit set by the database server for connection from the client. By setting up the timeout, the server will not wait indefinitely for client request, but will terminate its operation if it takes too long. There are several types of timeout, including connection timeout and waiting timeout. The connection timeout is the maximum amount of time between the client attempting to connect to the server and the timeout occurring. If the connection timeout is not successful within this time, the connection will be terminated. And the waiting timeout is the maximum amount of time that the server will wait for a client to send a request after a connection has been established. If the client does not send a request within this time, the connection will be terminated. Next is locking. Locking refers to the ability to control the concurrent access to the specific data in order to maintain database consistency and integrity. Locks are used to prevent data inconsistency and conflict when multiple transactions are running concurrently. When locks are enabled, other transactions must wait, which can reduce overall database throughput. And there are two types of locks, includes the shared locks and the exclusive locks. When shared locks are enabled, the other transaction cannot modify the data, but they can still read it. If exclusive locks are enabled, no other transaction can modify or read the data. From here, I will introduce the features of PostgreSQL on Azure. The PostgreSQL has a variety of unique features that allow for advanced development. And one of the important features is the PLPG-SQL. The PLPG-SQL is the procedure programming language for PostgreSQL. It can perform complex operations that extend the normal SQL. Since the PLPG-SQL is similar to Oracle's PLSQL, and you can easily integrate it with Oracle. The Azure database for PostgreSQL is a PaaS service, so you cannot configure some functionality below the platform layer. For example, you cannot configure server parameter, access level below the OS, or retrieve log file from the OS. Azure Database for PostgreSQL offers two deployment options, the single server and the flexible server. The difference between them are summarized in this table. From the flexible server, it is the deployment option that allows for more detailed customization and that takes advantage of the cloud benefit, such as auto-scaling and high availability. The single server is easier to set up and is used for smaller development. The flexible server is currently recommended. And next is this is the high availability architecture for Azure Database, and the image shows the redundant primary and secondary configuration with multiple availability zones. And normally, the database is running in the primary environment, and the data in the database is applied to the synchronously from the primary environment to the secondary environment. In addition, the application data and the logs file are automatically backed up on a daily basis. And the backup storage is also configured in the zone redundant manner, and this makes the architecture capable of withstanding the failure on a per region or per zone basis. Most of the PostgreSQL users uses a tool called the PG admin. The PG admin is a GUI tool for managing the PostgreSQL database. Using the PG admin, you can manage the database and execute SQL. You can also PG admin to manage your database on Azure. Again, a different database engine offers different features and functions. While those detailed features will not be tested on the certification exam, but from the practical standpoint, you should take them into the consideration when choosing which database engine to use. Next, I'm going to introduce non-relational database. In this chapter, I will introduce Azure Storage and Azure Cosmos DB. Azure Storage is the storage service provided by Azure that can store any type of data, including unstructured data. The Azure Cosmos DB is a NoSQL database service provided by Azure. It supports the databases such as a key-value database, the column family database, a graph-oriented database, and a document-oriented database. The object storage is used for the storing data as object, which also known as the blobs. Each object typically includes the data itself, metadata, and a unique identifier. The object storage systems allows you to retrieve an object via HTTPS, which is used for the web-based content. The object storage is highly scalable and used for many use cases, including the archiving, backup, storing large volume static data like image, audio, video file, and document. And in Azure, Azure Blob Storage is offered. The block storage is an architecture that divides the data into blocks, each with a unique identifier. These blocks work like individual hard drives. The block storage is used in the storage area network, where data is stored in the volumes, also called blocks. It offers high performance and low latency, which is suitable for environments like databases, where rapid read and write operation are necessary. In Azure, Azure Disk Storage is provided. And file storage is the hierarchical storage used for organizing the data files. It is used for the regular file system, personal computers, and servers. And this is probably the storage type you are most familiar with, at least it's the most widely adopted consumer product. It can be shared among the multiple clients using the standard protocol such as NFS or SMB. And in Azure, you can use Azure File Storage. I'm going to introduce the storage accounts. In Azure, you need to create a storage account to use the storage services. You can create and access Azure Portal, CLI, as well as the endpoints. You can access via the endpoint as described here. And the name of storage account is included in the endpoint, so the storage account name must be unique in the region. The Azure offers 4 types of storage accounts depending on the data format. From the top, there are the blob, file, the table, and the queue. The table storage is the schemaless table, which is equivalent to the NoSQL database. And the queue storage is the messaging store for asynchronous connection between the applications. I'm going to introduce details of blob and file storage on the next chapter. At this time, the storage accounts have different pricing plans as listed here. And there are 2 major categories, standard and premium. And with the subcategory, the storage version 2, the blob storage and the file storage. And the storage version 1 is currently not available. The standard is the HDD-based storage, and which is suitable for storing the large amount of data at a low cost. The premium is SSD-based and is a performance-oriented storage type. Azure Storage provides different options for data redundancy. which ensures your data is replicated to the safeguard against the unexpected hardware failure and to meet the compliance requirement. I'm going to introduce each options. And firstly, locally redundant storage, or LRS, replicate your storage account 3 times within a single data center in the primary region. And this is the simplest redundancy option. The zone redundant storage, or ZRS, replicate your storage account synchronously across the 3 availability zones in the primary region. And each availability zone is a separate physical location with the independent power source. The GRS, or geo-redundant storage, your data is replicated in the secondary geographic location that is far away from the primary location. If the primary location becomes unavailable, the Azure storage fails over to the secondary location. However, with GRS, the data in the secondary location is not available for read and write access unless the Microsoft initiates the failover. With RAGRS, or Read Access Geo-Redundant Storage, and this takes the GRS a step further by providing the read-only access to the data in the secondary location, even if the primary location is still up and running. The RAGRS is designed for applications that require high availability and durability. It is more expensive than the GRS because it offers additional read access to the secondary region. The Geo-Zone Redundant Storage, or GZRS, combines the high availability provided by the redundancy across the availability zones with protection from the regional outage provided by geo-replication. The data in a GZRS storage account is copied across the 3 Azure availability zones in the primary region, and is also replicated to the secondary geographic region for protection from the regional disasters. Lastly, with Read Access Geo-Zone Redundant Storage, or RAGZRS, you can read the secondary region even if the primary location is still up and running. And this is the summary of redundancy option. Basically, the lower you go, the higher the availability. The availability of LRS and ZRS is guaranteed to be at least 99.999999%, 11 nines, and the availability of others are over 16.9. And I highly recommend you memorize these redundancy options as they appear frequently on the exam. The exam test frequently asks you to choose the correct redundancy option, focusing on whether or not the secondary region can be accessed during the normal time as well as in the event of failure. And again, with the read access option, you can access to the secondary region even in the normal times. I'm going to introduce the Azure Blob Storage. The Azure Blob Storage is a service for storing the large amount of unstructured data, such as text or binary data, which accessible from anywhere in the world via the HTTP or HTTPS. The Blob storage has many use cases. The common use includes the serving images or documents directly to the browser, storing the file for distributed access, streaming the video and audio, writing to the log file, storing the data for backup and restore, and disaster recovery and archiving. The object storage does not have the hierarchical structure. On the other hand, by setting up the container, data can be managed like file storage, and you can access through the endpoint URL with container. The blob storage offers three types of blob: the block blob, append blobs, and the page blob. The block blob is used for storing the text and the binary data up to about the 4.75 TB, and they are made up of the blocks of data that can be managed individually. The append blob is optimized for append operation, making them easier for scenarios such as logging data from virtual machine. The append blobs are appended to block blobs. Append blobs do not have independent identifier, but inherits the identifier of block blob. The page blob is up to 8 TB in size and more efficient when ranges of bytes in a file are frequently updated, like as a disks or for the virtual machine. The blob storage has the concept of access tiers. The access tiers include the hot, cool, and archive. The frequently accessed data is stored in the hot layer, infrequently accessed data in the cool layer, and the rarely accessed data in the archive layer. The storage costs are higher for hot and lower for archive. On the other hand, with respect to retrieval operation, hot is cheaper and designed for quick data retrieval. The cool and archive have a minimum storage period. For example, if you delete the data in cool layer less than 30 days, but you will still be charged for 30 days of storage. And you can also use the lifecycle management. For example, the data that has not been accessed for 30 days can be automatically migrated from hot tier to cool tier. As a point of reference, S3 of AWS and the cloud storage of Google Cloud can be configured for lifecycle management as well. The AWS has a more fine-grained access tier than Azure. And next is the file storage options. The Azure files offer free managed file shares in the cloud that are accessible via the SMB or NFS protocols. The Azure file shares can be mounted concurrently by cloud or on-premises deployment of Windows, Linux, and Mac OS. The Azure file also has a storage tier, the Premium, Transaction, Optimized, Hot, and Cool. The Premium uses the SSD and has a high throughput performance. However, it is more expensive. The HDDs are used in the Transaction, Optimized, Hot, and Cool. Basically, the higher you go, the higher the storage cost, while the transaction fee is lower. The Azure File Sync offers a smooth transition between the cloud and on-premises. It transforms Windows Server into a quick cache of your Azure file share, which enables you to maintain local access to your files. You first install the agent on servers and register them on Azure portal, and next configure the sync group, cloud endpoint, and server endpoint. Next, I will introduce Azure Table Storage. Azure Table Storage is a NoSQL storage solution with keys and values. It doesn't have the strict schema structure, and is classified as the semi-structured data. Azure Table Storage also doesn't support normalized expression, foreign key, the stored procedure, and views. Azure Table Storage has keys called partition keys and row keys. And the row key uniquely defines the item in each row. On the other hand, the partition key can improve the performance and the scalability by dividing the table into the multiple partitions. The table storage makes the table be partitioned by partition keys. Since the partitions can be handled independently, you can add and delete rows for each partition. And also, the partition makes the input and the output operation more efficient. For example, if you have a large number of rows, it would take a long time to search the entire table. But by specifying the partitions, you can narrow down the search target. As a result, the performance is improved. I will start here by introducing you to how to protect your storage. Azure Storage offers a variety of features to keep your data safe. The image is one I presented at the Key Management service. You can enable encryption for both data in transit and data at rest in storage service as well. The Azure provides several endpoints that can be used to improve the security. And it also provides fine-grained access control and soft delete. I will describe these in detail starting on the next page. You can control access by RBAC, role-based access control, which I have explained in the governance chapter. For example, if you want to grant a specific action for storage, you list the action with the Microsoft.storage. You can use several encryption methods for storage service. The storage service encryption SSE is to automatically encrypt your data before persisting it to Azure Storage and decrypt it before retrieval. The client-side encryption allows you to encrypt data within your client application before uploading it to Azure Storage and decrypt the data when you download it. And these are the encryption methods for data at rest. In addition to this, Azure Storage provides the HTTPS encryption for data in transit by default. A shared access signature SAS is a secure way to grant limited access to your storage account resources without exposing your account keys. A SAS provides delegated access to resources, in which you can specify what kind of resource and how long the SAS is valid and so on. And this is an example SAS URL. And here is a breaking down of the URL and what each parameter means. Resource, service version, start time, and expiry time. The signed resource and B stand for blob storage, and signed permission and R stand for read permission, and signature. In addition to these elements, you can configure IP address ranges and HTTPS protocol. The SAS is used for sharing the object to a specific number of users, but is usually used for the temporary file sharing purpose because of the risk of leaking the URL. I will explain other security features related to the storage account. The soft delete is a logical deletion feature which temporarily preserves the data that are deleted, allowing you to restore them if accidentally deleted. As for endpoint, you can use private endpoint, which provides a secure connectivity over a private link. And you can also use the service endpoint, which is a secure and direct connection between your virtual network and the Azure service over the Azure's backbone network. The backbone's network is a Microsoft's own network. You can use the backbone network to transmit data without the influence of the internet. For more information on the network service, I will introduce that in the next chapters. From this page, I will introduce Azure Cosmos DB. The NoSQL database are more flexible databases that have expanded since 2000. Compared to relational database, the NoSQL database have more flexible schema structure, and the new types of database have been added to accommodate all types of data. Azure Cosmos DB is a NoSQL database provided by Azure. It offers column family, key value, graph-oriented, and document-oriented database types. It replicates data in Azure's worldwide data center and offers high availability. Starting from the next slide, I will introduce the architecture and the API of the Cosmos DB. I will introduce partitioning in Cosmos DB. The partitioning allows the database to be divided into appropriate units to improve the scalability and performance. Partition keys are selected based on the queries and access patterns. For example, in this example, the item city is selected as the key, and this assumes that the users will frequently access and query using the key city. And there are two types of partitions, the logical partitions and the physical partitions. A logical partition is a collection of items that have the same partition key. In this example, the items with the same city are stored in the same partition. The Cosmos DB internally computes the hash values and maps the data to physical partitions. When the amount of data in the logical partition becomes large, it is stored across the multiple physical partitions. The Cosmos DB automatically scales the physical partition as needed. The hash calculations are done internally by Azure, so you don't need to take this into account. You are responsible for selecting the appropriate partition key according to your system and the business requirement. The physical partitions are replicated within the same region to improve the redundancy. They are also replicated across the multiple regions to further enhance the redundancy. And this design ensures that operations are not affected in the event of regional failure. When setting up the partition keys, you consider the data to be evenly distributed among the logical partitions. Also, make sure that there is no bias in throughput. If data or throughput is unevenly distributed, it will affect overall performance. It is recommended that the partition be divided evenly to avoid slow query and access. For reference, the maximum size of each partition is 10 GB. The Cosmos DB provides several APIs. The API stands for Application Programming Interface and is a set of interfaces to access data from database management systems and software. The APIs are provided for each type of the database, and the Cosmos DB provides the APIs listed in this table. I will introduce them with the samples from the next page. And this is an example of document database. Now, the Cosmos DB contains some data described in the JSON. And the name of the database is product. Execute a query to retrieve the all item of the document data whose ID is 12345. The query has the same syntax as the standard SQL. And the query will return the data with ID 12345 as shown here. And next is the MongoDB example. It is similar to the document-based database described earlier. The MongoDB's data type is based on the JSON. Now, execute a query to get the data whose ID is 456, and the MongoDB query looks like this. And the query result will return data like this. And next is an example for PostgreSQL. This query is in the same format as the query introduced for the relational database. Gets the product name and the price of the record with product ID 123 from the table named product. And this is the result of the query. And the next example is Apache Cassandra, which is a column family database. The Cassandra uses a query called CQL, the Cassandra Query Language. The syntax of CQL is similar to standard CQL. If you execute a query similar to the one just like PostgreSQL, the query returns the data with product of 123. And finally, a graph-oriented database. Azure supports Apache Gremlin. The Gremlin is an open-source database used for graph-oriented database. The Gremlin uses a node and edge to the form of the graph structure. And here, the employees and their relationships are represented by the node and edge. And here is the sample of Gremlin API. The first, add an employee node and add properties. The property includes the employee ID and first name. And here, add an employee named Alice with the employee ID 3. The query g.addv adds the node. And similarly, you can perform the operation such as deleting or updating a node. And next, add an H representing the employee's relationship. Add an edge called report to from the node with the employee ID 3 to the node with the employee ID 1. And finally, here is the example of a query that retrieves employee node ordered by ID. Now, there are 3 nodes in the graph, so the query result will be return 3 nodes and their properties. And so far, I have explained some sample of the type of the database and API provided by Cosmos DB. The Azure provides the multiple NoSQL database in a single service called Cosmos DB. Next, I'm going to introduce data analytics. To understand the data analytics, you need some basic knowledge first. The DP-900 certification exam will not test you on the specialized knowledge, but in this section, I will introduce some common basic knowledge about the data analytics. First, I will introduce the recent trend in the data analytics. Since around 2010, the circumstances of the data analytics have been evolving. With technological developments such as the smartphones, IoT, and nowadays the generative AI, the world of data analytics is becoming increasingly complex. The company systems are becoming faster, the business data is diversifying, and data formats such as the batch, stream, and unstructured data are diversifying, and the data analytics methods themselves are also diversifying. The demand for the data analytics is increasingly in these uncertain and fast-changing time. The series of the steps from the collecting, the processing, and analyzing the data is called the data pipeline. And this is an image of a typical data pipeline. From the next page, I will present the detail of each of these phases. I will explain for each phase of the data pipeline. In the first phase, the data is collected from the data sources that includes a variety of the data types. There are the structured data, unstructured data, and many other data types. There are also the differences in the time series, such as batch and streaming. As I mentioned before, there are types of the data: structured, unstructured, and semi-structured data. The structured data is organized in a specific format, usually stored in a relational database. It's in the table with rows and columns, with a specific data type and format. And because of this structure, it's easy to scan and query. Unstructured data doesn't have a specific format or structure. It's more complex and harder to process because it doesn't have a schema definitions. And semi-structured data is between structured and unstructured data. It has some structure for analysis, but not much as the relational databases. Another way to classify data is by how and when it's collected. Batch processing means collecting, storing, and processing data in a group after a certain amount of time, or when a certain amount of data has been collected. The data is collected over time and then processed in batches. For example, the data from a specific day is processed once every 24 hours and sent to another system in batches. The streaming means processing data in real time as it arrives or is generated. The data is processed immediately after it's created or received. The streaming usually needs more data capacity and computing power. Next, I will introduce data lakes, data warehouse, and data marts. A data lake is a storage repository for raw data, including the structured, semi-structured, and unstructured data. A data is stored in its raw state without being pre-processed. It is typically designed to be highly scalable and flexible. Data lakes use technology like Spark and Hadoop to process the query on the stored data. A data warehouse is a storage system used for reporting and data analytics. The data warehouse stores data formats for their use cases. The data is processed through the ETL process. The data warehouses are not transact but have schema design optimized for data analytics. Therefore, they are suitable for analyzing data after it has been stored, and not for the process of getting the data into data warehouse. A data mart is a subset of the data warehouse. A data mart is a scaled down the data warehouse with a more focused scope. The data mart speed up query by limiting the amount of data to be scanned, since they are only target to specify the range. And there is also a concept of the lake house, which is combination of data lake and the data warehouse. A star schema is a common model for data warehousing. It has a central fact table and several dimension tables. It is called a star schema because it looks like a star shape. A snowflake schema is a normalized form of the star schema with a more segmented dimension table. The name comes from the shape of a snowflake. In a snowflake schema, normalization reduces the data redundancy and improves the data integrity. And this table shows the difference between the star schema and the snowflake schema. A star schema has a central fact table and directly connected to the dimension table. The tables are denormalized, making them good for simple queries. But because they are normalized, the data storage efficiency and integrity are usually low, and the star schema are used for both small and large data warehouses. And the snowflake schema, on the other hand, have a highly normalized table structure. They have higher data integrity and used for large data warehouse. And I will explain what the dimension table and fact tables are. A dimension table has attribute data. The dimension table gives you the context to the data in the fact table. For example, the dimension includes the data, the customer, and the product. And these dimensions helps analyze data from the different angles: sales by date, sales by customer, and sales by product, and so on. And the fact table have the numerical information. For example, they store actual data like sales volume and sales quantity. And by linking a dimension table and a fact table, you can perform the detailed data analytics. Next, I'm gonna introduce ETL. The ETL stands for extract, transform, and load. The extract means the getting the data from the various sources like RDBs, CRMs, and flat files. Transform means changing the extracted data into the format suitable for the target database or data warehouse. And this includes the cleaning, the filtering, the validating, aggregating, enriching, and the reformatting the data. And load means putting the transformed data into the data warehouse or other target systems. The ETL is traditionally used in the batch processing system, where the transform happens before the loading the data. The ELT, on the other hand, transforms the data after it is loaded into the target system. With the cloud-based data warehouses like the Snowflake, the Google Cloud BigQuery, and Amazon Redshift, the ELT is becoming more popular. And I will use a simple example to show what data processing looks like. And here is a simple list with name, phone number, email address, and age. And there is a duplicate John Bow in the name field. The remove duplicate if you need the unique data. And the phone number must be numeric, but their alphabetic character mixed in. In the same way, correct them or remove them. and there is a space in the email address field, you can eliminate the space, leave it as it, or replace it with another character. And there is an impossible age of 150 years old, which also needs to be corrected. If you find irregular values, usually define rules to convert them to the correct form or delete them during the data processing. And this is like a not null constraints and deduplication in the database service. The data cleansing is a part of the transform step in the ETL process. In real business, the raw data often has missing or incorrect values, which can be properly processed to improve the accuracy of the data analysis. And finally, I will introduce analysis and visualization. The business intelligence, or BI, are used to analyze and visualize the data from various sources to provide the business insight. The BI tools help to make the managerial decision by giving a visual view of the business metrics and performance. And Microsoft offers a tool called the Power BI. And the traditional data analysis involves the processing data using the SQL queries. Today, the data analysis methods are diversifying, and recently, generative AI has become more accessible and has impacted the business. The machine learning involved the complex analysis based on the multivariate analysis and the statistics. Although data analysis requires specialized knowledge, the cloud has made it easier to perform these analyses. And here, I'm going to introduce the Gartner's 4-step model of the data analysis. The Gartner is an American research company. And this model shows how companies use the data to gain insight. There are 4 stages: descriptive, diagnostic, the predictive, and the prescriptive analysis. The descriptive analysis asks what happened, and it uses the historical data to understand the current situation. And the diagnostic analysis asks why did it happen, and it looks at a relationship and pattern in the data to find the cause of an outcome. And the predictive analysis asks what could happen in the future. It uses historical data, statistics, and machine learning to predict the future events and trends. And finally, the prescriptive analysis asks, what should we do? And it suggests the strategy and actions based on the insight from the predictive analysis. And these 4 levels of analysis help extract the valuable insight from the data and make better decisions. And this framework is also tested in the certification exam. And finally, here is an image showing the Azure services along the data pipeline. A data factory is used for data collection, and the database services and Azure Blob Storage for data storage. And for data processing and analysis, we have services like the one listed here, and Microsoft Power BI is also available as a BI tool. From here, I will introduce Azure services related to the data analytics. And first, I will introduce the Azure Data Factory. Azure Data Factory, or ADF in short, is a cloud-based data integration service. It automates the tasks like data migration, data transformation, and the ETL process. And and ADF is used to collect data from different sources. And these are the components that makes up the ADF. The ADF connects to the data source to perform the data integration task and then outputs the result to the destination system. The set of data handled by ADF is called a dataset, and the sequence of the data integration task is called the pipeline, and the pipeline can contain the multiple activities. The services associated with the ADF called the linked service. The ADF components are defined in JSON. ADF can connect to the many types of data sources. For example, it supports database services, the file storage, open source system, and various protocols. A linked service defines a connection to the data source, including the connection details, endpoints, and the authentication information. ADS supports the transforming collected data. It can also use external computing services during the process. For example, it can integrate with Azure Data Analytics services like HD Insight, Azure Data Lake Analytics, and Azure Machine Learning. Next, I will introduce Azure Synapse Analytics. Azure Synapse Analytics is the integrated platform that combines data warehousing, the big data analytics, and data integration and visualization. It's the successor to the Azure SQL Data Warehouse. It is integrated with the Apache Spark, so you can use Spark queries. It is highly scalable, allowing you to scale up or down your computing resources for large dataset. And this minimizes the latency during the heavy processing and optimizes cost when processing workloads are low. Starting in the next chapter, I will introduce the future of Azure Synapse. The large-scale data analysis system like Azure Synapse use massively parallel processing, the column-oriented storage to improve analysis performance. Now I will introduce the architecture of Azure Synapse. Azure Synapse consists of the control node and the multiple compute node. The compute node performs the analysis task, and the control node controls each compute node. The control node sends the instruction to the compute nodes for parallel processing. And this kind of process is called MPP, the massively parallel processing. In Azure Synapse, the computing resources and the storage resources are separated. With this, you can scale compute and storage independently. By scaling each resources as needed, you can avoid unnecessary cost. And in Azure Synapse, the multiple nodes share storage, and which is commonly called the shared storage. The sharing storage typically reduces the overall storage capacity. On the other hand, when compute nodes have their own separate storage, it is called shared nothing. And next, in Azure Synapse, large amounts of data are distributed across individual nodes. And there are three ways to distribute data: the hash algorithm, replicate, and the round-robin style. And with hash algorithm distribution, records are spread across the node based on the hash function. And this is used for joining and aggregating a large table. And in replication style, the all data is copied to all nodes, and this is used for small table. And the round-robin style is the most common method, where data is evenly distributed across all nodes. And on the next page, I will show an example of these distribution style using actual sample data. And here is an example of distribution. For example, and we have a customer and the order table. The customer table has the customer ID, customer name, and the customer email. It has a small number of records and is considered as a master table. The order table has the order ID, a customer ID, product ID, and the order date, and it has a large number of records, and that grow as the transaction increase. And when this table is joined with the customer ID as the key, a row with the same customer ID are stored in the same node, and which speed up in the joining process. And this is an example of a hash distribution. A hash distribution is suitable when you want to store the data in a specific node by a specific key. Next, let's talk about the distributed style replicate. And this method replicates data to all nodes. It is used for relatively small data. For example, the customer table is a master table, so it's a small and suitable for replicate. And this way, you don't need to move the data between nodes when performing a joining. Since the master table is frequently referenced, it's better to have it on all nodes. However, on the other hand, the replicate is not suitable for large table. For example, the order table grows with each transaction, so if it replicates to all nodes, the total data volume will be large and the cost will increase. And finally, there is a round-robin style. If you don't need to distribute by a specific key and the table size is not large, the round-robin distribute rows evenly. And these are the different distribution methods. I will introduce the column-oriented storage. In general, disk input and output, disk I/O, accounts for from 60 to 80% of the processing time in the database search operation. Therefore, the data warehouse achieves high performance by reducing disk I/O. The column-oriented storage stores the table in the column instead of the rows, and this reduces the I/O by storing the similar data in the same columns and only processing the needed columns. The column-oriented storage makes the data easier to compress and saves the storage and improve query performance. And you can also use the encoding in Azure Synapse. The column-oriented storage uses a technique called the zoning. The data is divided into the multiple zones, and the data is retributed based on the minimum and the maximum value in each zone. And search efficiency is improved by skipping the unnecessary zones. For example, the zones can be based on the dates and the processing patterns. To use the zone map effectively, the data is stored to improve the searchability. Azure Databricks is a lakehouse service provided by Azure, and this service was developed in the partnership by Microsoft and Databricks. It offers the first big data analysis environment based on the Apache Spark. And here is the Databricks architecture. And with Databricks, you can process data using Python or SQL, or develop AI model for analysis. And the result of your analysis can be shown in the dashboard or export to the Power BI. And you can also manage the pipeline of the processes within the Databricks. Azure Databricks is a service called the Lakehouse. A lakehouse is a term that combines the data lake and the data warehouse. A data lake is store the raw data from various sources in its original form. Since it stores raw data as is, it includes the different data formats, both structured and unstructured data. Also, the data lake handles both streaming and batch processing. Azure Databricks provides a unified data governance feature called Unity Catalog, and this allows for managing the various data types and schemas. The data is then converted into the Delta table, which manages the schema of the data. And the Delta Lake, a feature of Delta table, that collects the schemas by eliminating the missing values and duplicate data. And once validated, the data is processed according to the analytics application. And finally, the processed data is exported to external analytical or BI tool. A lakehouse must support real-time data processing, scalability for large data volume, the data governance, and integration with analytical tools. The Databrick has a structure called the medallion architecture. It consists of the three tiers, the bronze, silver, and gold. The bronze tier contains raw data from data sources. Raw data is added incrementally from the data sources. It can combine streaming and batch data to incorporate different time series. The silver tier stores validated data. Data is taken from the bronze tier and validated. For example, it performs the simple filtering and the deduplications. And the gold tier further processes and aggregates the data for analysis. The medallion architecture categorizes and manages the data by tier, making it easier to ensure atomicity and consistency. By classifying the data ingestion and processing hierarchy, it's easier to maintain the scalability. The medallion architecture is important for building the lakehouse that combine the data feature of the data lake and the data warehouse. Azure HD Insight is an infrastructure for large-scale data distribution. It features a Hadoop ecosystem in Azure. While Hadoop was initially used in the Linux environment, HD Insight allows it to run on the Windows, making it easy for users to use the Hadoop in the Azure cloud. Because it's available in the cloud, you don't have to build an environment yourself. To learn about the Azure HD Insight, you need to understand the Hadoop ecosystem. In the following pages, I will give an overview of the Hadoop ecosystem. From here, I will introduce the components of the typical Hadoop ecosystem. The Apache Hadoop is the de facto standard for analyzing the big data. It is widely used as the distributed infrastructure for large-scale data. And Hadoop and its major related tools are collectively known as the Hadoop ecosystem. The Hadoop uses the algorithm called the MapReduce to perform parallel processing on data stored in HDFS, which is distributed storage. Apache Spark is another framework for large-scale data processing, known for being faster than Hadoop. It improves the performance by doing the computation in memory and supports batch processing of large dataset, interactive queries, streaming, and machine learning tasks. Hive provides the HiveQL, a SQL-like query language on Hadoop for performing the complex query on large amount of data. HBase is a distributed columnar database on Hadoop that can read and write large tables in real time. Apache Hive and Apache HBase typically run on top of Hadoop. Presto is a distributed SQL query engine that can quickly extract information from the various data sources. And these frameworks are available in Azure HD Insight. You can perform big data processing immediately without having to set up the framework yourself. Now I will introduce the Hadoop configuration. HDFS is a distributed file system that spans multiple servers. Within these clusters, Yarn manages the resources like CPU and memory. The MapReduce is designed to perform the parallel distributed processing on Yarn. HBase offers high performance for read and write operation on large amount of small data. The HDFS is great for reading and writing large files with high throughput. However, HDFS is a file system, not a database management system, so it's not suitable for relational database operations. HBase and HDFS can be used together to complement each other. The MapReduce is a programming model designed for processing large amounts of data in parallel. It consists of the two main steps, map and reduce. And here is a simple sample data flow. The counts the words at the initial state. In the map step, the converts the word into a key and the number 1 as a value. In the map step, the model input and transform the data into a smaller set, into a pairs of keys and values. In the shuffling step, the grouping the same word. And finally, in reduce step, the aggregates the values of the data with the same key. During the reduce step, the model output from the map step aggregates the data for each key and generates the new pairs of the key and value. And this is the very simple sample. In practice, the map reduced to be applied to terabytes and petabytes of data. With Azure Synapse, you can use the standard SQL to execute the MapReduce process. Microsoft Fabric is a software-as-a-service data analytics tool from Microsoft. It integrates with the various data lake, the data analytics, and the business intelligence tools available on the Fabric. The Microsoft Fabric is an all-in-one data analytics tool. It works with the open source tools as well as Azure tools. It also includes the Microsoft AI Copilot by default. The Microsoft has a partnership with the OpenAI, and this service includes the GPT, OpenAI's large-scale language model. The Microsoft Fabric is a new tool and generally available in November 2023, so many features are in preview at this time. There is much room for new features to be added in the future. For certification exam, you will not be asked about the service, so this course only covers an introduction for your reference. The Power BI is a business intelligence tool from Microsoft. The Power BI visually analyzes data and provides insight. The BI helps companies make decisions based on data. The data can be easily aggregated, analyzed, visualized, and shared using Power BI. The Power BI has three main components. The Power BI Desktop is a Windows desktop application. It lets you manage and visualize data on your desktop. The Power BI service is an online SaaS offering. You can use Power BI in your browser. And you can also use Power BI on your mobile devices. And I will introduce more components used in Power BI. The Power BI Report Builder is an advanced reporting tool. It's especially suited for creating the paginated report. With pagination, you can format the report for printing or exporting the PDF. The Power BI Report Server is an on-premise report server. It is useful for companies that want to create a report in their own environment. You can create the report in Power BI Desktop and publish them in the company's on-premise environment. Now, I will introduce to the main graph and chart available in Power BI. The Power BI offers a wide variety of graph and chart. Depending on the use case, you can visualize data from different angles to gain insight. And here the graph and charts provided by Power BI for each category. On the next pages, I will show you an images of each one. And first, here the chart used to compare the data. The column chart, bar chart, and the waterfall charts are representing the data in two dimensions on the x-axis and the y-axis. These charts are suitable for comparing the value between different categories. And the waterfall charts are especially useful for showing the continuous increase or decrease in the values. And next, a chart that shows the relationship among the data. Scatter plots and the bubble charts are good for exploring the relationship between the variable in the dataset. Scatter plots shows a correlation between two sets of data. A bubble chart shows the relationship between three numerical variables using the x-coordinate and the y-coordinate and the bubble size. And next is the distribution. Pie chart and the tree maps visually shows the distribution and the composition of data. And next is the structure. And this type of chart is good for showing the hierarchical structure and the importance of the data. The key influencer chart visually displays which factors are important to the result. A tree map visualize the size and the color of the data, showing the distribution and the structure among the data. Line and area charts are then used to track changes or trends in the data over time. And finally, radar chart visualize the compare and the performance of the multiple item and the category in the single chart. With Power BI, you can visualize and gain insight into your data using many graphs and charts. And you can choose the appropriate chart for your use case. In the certification exam, you will be asked to select the appropriate chart based on the use case and the data characteristics. Lastly, in section 4, I'm going to introduce official documentation, learning path, and the pricing calculator. Azure documentation is the official document provided by Microsoft. It covers various aspects of Azure, such as compute, storage, networking, and more. The documentation includes a wide range of topics, including the tutorial, the quick start, and the troubleshooting tips. It regularly updates to reflect the latest features so you can access to up-to-date information. And next, Azure Learning Path is the set of educational resources given by Microsoft. Each learning path typically consists of the series of the module that includes the instructional videos, hands-on labs. The learning paths are aimed at a different skill level, from beginner to experienced cloud professional, and they are often tailored to specific roles such as Azure administrator, developer, solution architect, and data scientist. And lastly, the pricing calculator is a tool which you can estimate the cost of Azure services before you commit to purchasing them. It's designed to help potential and current customers of Azure calculate cost. And you can select and configure Azure services, including the virtual machine. And you can customize the according to the region, tier, support option, and the other relevant parameters. You can save your estimate or export them in the various formats, and which can be useful for reporting or further analysis. And thank you for staying with me throughout this course. I also offer courses on AWS, Google Cloud, and Microsoft Azure. Stay tuned as I will expand my offering in the future. So, I would like to conclude the course here. Thank you very much for your attention over the period. I'm sincerely looking forward to the opportunity to meet you again. Thank you.